Hello everyone, this is the fourth video in the series IS 875 Part 3 2015 explained and also Part 2 of wind load calculation on roofs. In this video, we will continue with the previous pitch roof problem with overhanging portions. We will also discuss how to calculate wind load for a monoslope roof of a rectangular clad building. I hope this video will be helpful for you. If you have any question, feel free to ask in the comment box. Now these are the streamlines for different type of overhanging roof. This is the image for overhanging roof for pitch roof problem. And this is the image of streamline for overhanging roof of one horizontal building. And this is the streamline for overhanging roof for a monoslope condition. Monoslope truss, this type of thing will happen. Now, how to calculate the wind pressure for this different type of overhang portion. Now that we will actually get from clause 7.3.3.5. And as per this clause, the pressure coefficients on the top overhanging portion of the roofs shall be taken to be the same as that of the nearest top portion of the non-overhanging portion of the roofs. The pressure coefficients for the underside surface of the overhanging portions shall be taken as follows and shall be taken positive if the overhanging portion is on the windward side. Now for three different conditions are there. First condition is it will be 1.25 if the overhanging slope is downward. It will be 1 if the overhanging slope is horizontal, and it will be 0.75 if the overhanging slope is upward. For overhanging portions on sides other than windward side, the average pressure coefficients on adjoining walls may be used. So we will go for the calculation, but before that, let's quickly understand one concept. Suppose there is a slope, overhanging slope like this, and this is the overhanging portion. So it is downward. If it is downward, the value of pressure coefficient will be positive. It will be always positive for the bottom portion. The pressure coefficients for the underside surface of the overhanging portion shall be taken as follows and shall be taken as positive if the overhanging portion is on the windward side. So if wind is coming from this direction, then it will be windward side. And at that time, we will always consider it positive. Now what is positive? Now you already know that it will be positive if it is pushing a particular surface. If it is pushing a particular surface, it will be positive. If it is pulling, at that time it will be negative. So positive means wind is actually pushing the surface, and this value will be 1.25. It will be 1.25 if the overhanging slope is downward. If it is downward, it will be 1.25. If it is horizontal, like this is horizontal portion, at that time it will be 1. And it will be 0.75 if it is upward, like this. It will be 0.75. But for windward side, always it will be positive. It will be always positive when it is on the windward side. If it is on other side, then it may not be positive. And at that time, the average pressure coefficients on adjoining walls may be used. So that how we will calculate, we will see in the next slides. Now this is the condition. First, if we think, this is the condition of overhanging roof when the overhanging slope is downward. So here we will consider the value of 1.25. Here we will consider the value of 1.25. This is the condition of horizontal overhanging roof. Here we will consider the value of 1. Here we will consider 1. Here we will consider 1.25. And in this condition, the third condition for monoslope roof, not for monoslope roof, any type of roof, if it is the slope is upward. If it is upward, we will consider the value 0.75. 0.75. And always it will be positive. Positive means wind is actually pushing the surface. Wind is actually pushing the surface. Here also pushing the surface. Now the pushing is actually maximum when the overhanging slope is downward. Then the pushing is maximum. If it is upward, then the pushing is minimum among all these three conditions. Now why this is happening? Now to understand that why this is happening, we have to look for the wind flow pattern. If we look for this flow pattern, we will be able to understand. Now normally when wind is coming from any direction, normally when wind is coming, you will see, normally when wind is coming in windward side, wind will come like this from this direction, and there is one point, normally we say that point is stagnation point, below which wind will move like this and vortex will form like this, and above which wind will move like this, above which the wind flow will be on the upward direction and below which the wind flow will be downward direction, and one particular point will be there where there will be no upward and downward flow, and we say that point is stagnation point. Now this is the basic flow nature of wind. Now if we go for this figure, you will see that this point is almost the stagnation point, above which wind will move in the upward direction like this, and below which wind will move like this. Similarly for this figure also, here this is the stagnation point, this wind will move like this, and here wind will move like this. So this flow, this upward flow will go and directly hit the overhanging portion of the roof. And for this type of roof where the slope is upward, at that time this hitting will be little bit less, because when the slope is like this, at that time wind will hit like this, but when the slope is like this, wind will actually move like this. Some wind will move like this and some will hit. So at that time the value will be less and it will be 0.75, and here the value will be 1.25, and for horizontal condition the value will be 1. Horizontal condition the value will be 1, sorry, the horizontal condition the value will be 1. Now before going in the detailed calculation of this overhanging portion, first we have to remember the value of external pressure coefficients for walls of rectangular clad building. This thing I have already discussed in the second video. In the video of calculation of wind force, we have already calculated how to calculate the external pressure coefficient for one rectangular clad building for the walls. Now for our particular building, this is the same building which we have used for our previous day problem. Now the length of the building is 40 meter, the width is 25 meter, and eave height is 15 meter. Normally when we calculate the external pressure coefficient, we calculate up to eave portion. So for our building, h by w is 15 by 25, which is 0.6, and L by w is 40 by 25, which is 1.6. So 0.6 and 1.6. So for our particular problem, for our particular building, this is the case. H by w is in between half and 3 by 2. So if it is in between half and 3 by 2, then we have to consider this value, because our h by w is 0.6. So it will be in between half and 3 by 2. And our L by 2 is 1.6, which will be in between 3 by 2 and 4. So this is our condition. And this is the CP value for different cases. For 0 degree case, when wind is coming from 0 degree means wind is hitting the longer direction. When wind will hit the longer direction, this is the different, these are the different faces of the building. A, this will be B, this will be C, this will be D. When wind will come from 0 degree, the CP value for face A is plus 0.7. Plus means always pushing the face, 0.7. For B, it is minus 0.3. Minus means pull, so it will be minus 0.3. And for face C and D, it will be minus 0.7. Again, it is pull. So minus 0.7. Here also minus 0.7. So this is the condition, this is the CP value of the wall, for the wall, not for the pitch roof. For the wall, this is the condition of CP. Now if the wind angle is 90 degree, then again this is our building, A, B, C and D. So for face A, CP value will be minus 0.5. Minus 0.5 means this is minus 0.5. Minus means pull. For face B, it is again minus 0.5. For C, it is plus 0.7. And for D, it is minus 0.1. Minus 0.1. Now, why this is happening? Because wind is coming from 90 degree. 90 degree means wind is hitting the shorter side of a particular building model. At that time, C will be the windward face and D will be the leeward face, and face A and B will be the side faces. So at that time this will be the external pressure coefficient. Now the details of all this value I have already discussed in one previous video. You can check that if you want to know why these values are coming like that. Now this is the top view, and again these are the CP value. Again I am saying that this is when wind angle is 0 degree, this is when wind angle is 90 degree. When wind angle is 0 degree, for phase A CP will be 0.7, for phase B CP will be minus 0.3, for phase C and D it will be minus 0.7 and minus 0.7. Minus means pull and plus means push. So here for side to side face and the leeward face it will be suction, and for the windward face it will be pressure. Now when wind angle is 90 degree, at that time for phase A the value will be minus 0.5, for phase B it will be minus 0.5, for phase C and D, for C it will be plus 0.7 and for D it will be minus 0.1. And why this is happening? Because wind is coming from 90 degree, and at that time this will be the windward face and this will be the leeward face. All these values are actually required when we will calculate the wind load for the overhanging portion, because wind will come from 0 degree and 90 degree. So different portion will come in different condition. So at that time the external pressure coefficient of this particular walls are actually required for calculating the wind pressure on the overhanging portions. Now this is the previous day problem, when we have calculated the value of CPE, CPI and also CP minus CPI for one particular pitch group, and this is when wind angle is 0 degree and CPI value is plus 0.5. Wind angle 0 degree, CPI is plus 0.5. That means opening area is in between 5% to 20%. Opening area in between 5% to 20%, and wind is hitting the longer side of one building. That means wind is coming from this direction and it is hitting the longer side of a particular building. So this is 0 degree. Now we have already calculated the value of CP, CPI and CP minus CPI, because wind force is equals to CP minus CPI into influence area into PD. So we need the value of CP minus CPI. So we have already calculated the value of CP minus CPI for this roof portion. But what about the overhanging portion? So what about the overhanging portion? Now this is the top portion, this is the top of the overhanging portion. So as per the clause, we know that for this top portion the upward CP value will be minus 1.5. That means same with the non-overhanging portion. Just this is the overhanging portion, and just beside this particular portion for the non-overhanging portion the value we will consider for the overhanging portion. So here we will also consider minus 1.5 and here we will consider minus 0.5. Same like the non-overhanging part just beside this particular overhanging part. So this value will be same for the top, and for bottom here we will consider how much. This is the case of slope with downward slope, overhanging portion with downward slope. So here the value will be 1.25. So how much will be the resultant value? It is minus 1.5 and from downward it is 1.25. So both are actually acting on the same direction. So it will be, here it will be 2.75. 1.5 and 1.25. The summation will be this will be 2.75. And here it will be how much? Here it will be at top it is minus 0.5, and for bottom how much it will be there? For that we have to know the external pressure coefficient of the wall, because for windward side we will consider the value 1.25 or 1 or 0.75 based on the condition, but for the leeward side or any side face we will consider the external pressure coefficient for the adjoining wall. This is the adjoining wall. So here what is the value of CPE? So now our wind angle is 0 degree. That means wind is coming from this direction. So now for our roof, the roof is actually adjoining with this particular wall. This wall is actually B. This is A, this is B, this is C and D. So for B, the CPE value is minus 0.3. For 0 degree wind angle, the CPE value for B is minus 0.3. So here at top it will be minus 0.5, here it will be minus 0.5, at bottom it will be minus 0.3. Bottom minus 0.3 means like this. Minus 0.3 means like this and it will be pull. So this minus 0.5, this is also pull but in the outward direction, and this is minus 0.3. So the resultant will be here minus 0.2, minus 0.5 minus minus 0.3. It is actually minus 0.5 minus minus 0.3. So it will be minus 0.2. So here the value of resultant value of CPE will be minus 0.2. Here we cannot say this is CPI because this is not the internal pressure coefficient. This is also external, but it is acting in the opposite direction. It is acting on the opposite direction and the value is minus 0.3. Minus 0.3. And here it is acting on the same direction and it is 1.25. It is 1.25. So these are the value of pressure coefficients, and we have to consider this when doing the calculation of design wind force. Now when CPI is minus 0.5, again the calculation will be same because the change will be inside the building. Change will be inside the building. It is minus 0.5. So CPE minus CPI, this value, all this value will actually change. But here actually the value will be minus 1.5. Same with the adjoining part, and at bottom it will be 1.25. And positive means always pressure. Positive means pressure push. And here it will be again minus 0.5. And at bottom it will be the external pressure coefficient of the wall, which is minus 0.3. So again it will be minus 0.3. So the resultant will be minus 0.2. Here it will be minus 0.2. But in this zone it will be high. In this zone it will be high. It will be minus 1.5 minus 1.25. So it will be minus 2.75. And it is quite high. In this zone, in this overhanging zone, it will be quite high and it will be 2.75 outward. So it will be minus. So now when wind angle is 90 degree and internal pressure coefficient is plus 0.5. Wind angle 90 degree means this is our pitch roof and wind is coming from this direction, it will be 90 degree. So when wind will come from this direction, this will be CPE, and at bottom this will be CPI. So this will be same like the previous problem, and we will calculate the value of CPE minus CPI like this. But what about the overhanging zone? Here at the upward portion of the overhanging zone, it will be same like the adjoining part of non-overhanging zone. This same value will be there, so it will be minus 1.5. And here it will be minus 0.8. But how much value will be at the bottom? At bottom. Here it is downward slope, but this is not the windward direction. For previous condition, when wind was coming from 0 degree, at that time this slope was windward slope. But when wind is coming from 90 degree, at that time when wind is coming from this direction, now this slope is not overhanging slope. Now this slope is not windward slope. So now this slope is different slope. So now we cannot consider the value 1.25 or 1 or 0.75. So what value we have to consider? We have to consider the value of the adjoining wall of this wall. So how much is the CP for this wall? For that we have to know the external pressure coefficient of this wall. So now when wind is coming from 90 degree like this, at that time the CP of this wall will be minus 0.5, and here also it will be minus 0.5. Minus means pull, not push. So it will be minus 0.5 here, and here also minus 0.5. So how much resultant will be for this portion? For this portion the resultant will be minus 1.5 minus minus 0.5. So it will be minus 1, because minus 1.5 is acting outward, upward, and minus 0.5 is acting downward, inclined but downward. So both are acting on two different direction. So the resultant will be minus 1. And how much will be for this portion? At top it is minus 0.8, same like the adjoining portion, and at bottom it will be minus 0.5. So it will be minus 0.8 minus 0.5. So it will be minus 0.3. So here the resultant will be minus 0.3. So for this portion, the CP resultant, we cannot say CP minus CPI, but this is actually the resultant CP will be minus 0.3. Here the resultant is minus 0.8. Now when wind angle is 90 degree, but CPI is minus 0.5, the internal factor will actually change. This resultant of CP minus CPI will change. But for overhanging portion, the logic will be same. Outward it will be minus 1.5, same like the adjoining part, and here it will be minus 0.8, same like the adjoining part. Here the value and here the value will be same. At bottom, these two bottom are again, these are the side faces. These are the side faces. So the value will be minus 0.5. Here also minus 0.5. Minus 0.5 means pull, and minus 0.5 is again pull. Minus 0.5 is again pull. So resultant here will be minus 1.5 minus minus 0.5. So it will be minus 1. And here resultant will be minus 0.8 minus minus 0.5. So it will be minus 0.3. Same like the previous case. So this will be the resultant CP, and considering this value we can calculate the wind force for this particular overhanging portion. Now using the same logic, like this is the resultant CP, and multiplying it with CP resultant, we can say this is not CP minus CPI, you can say CP resultant, and in area into PD. So for overhanging portion, if we know the area, then the resultant CP into PD, we can calculate the wind force for this particular overhanging portion. Now these are the flow lines for monoslope roof. Now for monoslope roof, it means that in one side the height of the building will be little bit high than the other side. That means for monoslope roof, one side will be higher than the other side. One side will be higher than the other side, and normally we consider the lower side as H. For previous case, for pitched roof, we have considered the eave height as H, but here we will consider the lower side as H. So now when wind will hit this direction, it will be 0 degree. When wind will come from this direction, it will be 180 degree. That means when wind will come from this direction and it will hit the shorter side of monoslope roof, at that time it will be 180 degree. When wind will come and hit the taller side, it will be 0 degree. And when wind will come perpendicular, it will be 90 degree. And then this is for 45 degree. This is 45 degree. Here wind is coming like this. This is when wind is coming from this direction. This is 90 degree. This is 90 degree. This is not 90 degree. This is 90 degree. That means wind is hitting the shorter direction, but coming from front, because this is the pressure, positive pressure. So wind is coming from this direction. It is 90 degree. It is 45 degree. And it is 135 degree. 135 degree. So the wind is like that. Here it is 0 degree, 45, 90, 135 and 180 degree. Here 45 degree, 90 degree, 135 degree, 180 degree. So we can consider like this. Now for different conditions, these are the wind pressure distribution. And here you can see that this is when wind is coming from 0 degree, 45 degree, 90 degree, 135 degree and 180 degree. Now when wind will come from any direction, here you will see that in this zone there will be some flow separation. Like this, wind will flow like this, move like this, and here in this point flow separation will occur. And in this zone suction will be more. In this particular zone, just after the flow separation point, in this zone the suction will be more. So in a particular zone, if flow separation occurs, suction will be more. in that particular zone we have to consider the local coefficient. Here wind angle is 45 degrees, so wind will separate like this. Wind will flow like this, and this is the zone of local suction, huge local suction. For 90 degree, this is the zone of huge local suction because flow is moving like that. And here for 135 degree, all these zone are actually zone of maximum huge local suction. Here wind is coming from this direction and moving like that. So here also there will be flow separation. I have discussed about this flow separation in the previous video in detail, so you can check that video also. Now here for 180 degree wind is coming from this direction, and again in this point the flow separation is occurring like this. So just after the flow separation point, in this zone there is huge amount of local suction, local suction. Now how much is the value that we will get from the table? Now this is the table for calculation of CPE for different roof angle. For different roof angle the values are given. For 5 degree, 10 degree, 15 degree, 20 degree, 25 degree, 30 degree, for different roof angle the value of CPE are given. Now one thing we have to remember that here actually for monoslope roof the value of CPE is independent of H by W or L by W ratio. Whatever may be the value of CPE is only dependent on, this is only dependent on roof angle. Our CPE will be independent of H by W and L by W ratio. So suppose for a particular building the roof angle is 10 degree. At that time we will consider this particular case. So if wind is coming from this direction it will be 0 degree. Here this angle is theta, That means when wind will come from this direction it will be 45 degree. When wind will come from this direction it will be 90 degree. It will be 135 degree and it will be 180 degree depending on the wind direction. So now when wind is coming from 0 degree, for the H portion the value will be -1 and for the L portion the value will be -0.5. -1 and -0.5. Here -0.5. -1, -0.5. So how much is H? H is this portion. And our code is saying area of H and area L, area H and area L refers to the whole quadrant. This means H and L is total. This is H and this is L. We will consider for the total roof, we will consider this side as H and this side as L. H is on the higher side. On the higher side of a roof, like suppose this is the monoslope roof. The higher side, in this side there will be H and in this side there will be L. And in the H side the value is -1 and in L side it is -0.5 when wind is coming from 0 degree. So when wind is coming from 0 degree like this, at that time for H the value will be here, H the value will be -1 and for L the value will be -0.5. So it will be like this suction. So it will be like this perpendicular to the plane. So -1 and -0.5. When 45 degree, then for H it will be -1 and for L it will be -0.8. So for 45 degree the value is more for L than 0 degree. When wind is coming from 90 degree means this direction, this is 90 degree. So at that time H and L for both case star is actually applied to length W by 2 from windward end. W by 2 is how much? W is the width, and for our problem if we have to consider the W, and up to W the value will be -1. After that it will be -0.5 for both H and L. That means up to certain length, up to W, here the value will be -1 and after that the value will be -0.5. So how much is W? We will go for a real life problem and then we will see how much is W. When 180 degree, wind is coming from this direction. At that time for H the value will be -0.4 and for L the value will be -1. And taking this value we can calculate. Simply we can calculate. But apart from that, the most important part will be the local part, local coefficient. H1, H2, L1, L2, HE and LE. H1 is this portion is H1, here it is written H1. H1 is actually that portion which is on the higher side of the building. That means if we think like this is the building, monoslope roof, this is the higher end, this is the lower end, this is the lower end, this is the higher end. At that time we will consider this as this is our H1, and up to how much length? Up to W. Up to W this will be H1. And how much is H1? H1, how much length we have to provide? And that is Y. Y is H or 0.15 W, whichever is lesser. Like our previous day problem, Y will be H or 0.15 W, which one is lesser? Based on that we have to consider the Y. So H1 is this position, H2 is how much? H2 will be rest. H2 will be rest. This is H2. For that we will consider minus 1.5. This will rest will be H2. This will be H2. This will be H2. Similarly, up to W it will be L1. Rest will be L2. Rest will be L2. Now when we will consider wind from different direction, it will be H1. This will be H1. The opposite part will be H2. It will change, because when wind is coming from 0 degree, when wind is coming from this direction, this is 90 degree. At that time this will be H1, this will be H2. When wind will come from this direction and it will be 270 degree, at that time this will be H1, rest will be H2, and it will be L1, it will be L2. So best is if we consider the higher value. If for whole this local portion, if we consider the higher value, then it will be better for us, because at that time we will be on a safer side. Now this is H1, H2, L1, L2, L1 is minus 2, L2 is minus 1.5, same like H1 and H2, and HE and LE is minus 2. HE and LE are this particular portion. HE and LE are this particular portion. This is HE, this is LE. That means when wind is coming from 90 degree, this particular portion, this will be in local suction, and at that time we have to consider the value of minus 2. Minus 2. When wind will come from 0 degree, this particular zone will be critical. This particular zone will be critical, for which we will consider local coefficient of minus 2. And after that portion, after the corner side, we can consider the value of minus 1.5. But if it is better always that we consider for all this local zone, it is better if we consider the value of H1, which is minus 2. H1 which is minus 2. If we consider this value, it will be better. Similarly, for the opposite side, if we consider L1, then it will be better, because for L1 the value is minus 2. L2 the value is minus 1.5. So it is always better if we consider the value of L1 throughout this particular local zone, local separation zone. It is better if we consider the value of L1, because L1 is more than L2. So at that time it will be better. So now if we see the clean image, this is one problem, and same like the previous problem, the length of the building is 40 meter. This is 40 meter. Length is 40 meter, width is 25 meter, and height of the lower portion is 15 meter, and pitch angle is 10 degree. Suppose this is one problem. This is one building. This is one problem. And here the height by W, H by W ratio is 0.6, H by W ratio 0.6, and L by W ratio is 1.6. So like the previous problem. So here our CPE for the side faces for the wall will be like this. For 0 degree, when wind is coming from 0 degree, this is 0 degree. For face A it will be plus 0.7 push, positive means push. For face B it will be minus 0.3 pull. For face C and D it will be minus 0.7. Again it will be pull. When wind will come from 90 degree, at that time for face A it will be minus 0.5, B it will be minus 0.5, for C it will be plus 0.7, for D it will be minus 0.1, like this. So this is the condition. So now for our case, the roof angle is 10 degree. Roof angle 10 degree means this angle is 10 degree. This angle is 10 degree. 10 degree. And this is the higher end H, and this is the end L. wind is coming from this direction, this is 0 degree. If wind comes from this direction, it will be 180 degree. Because for monoslope roof, we know that if wind hits the taller portion, taller side, then it will be 0 degree. If wind hits the shorter side, it will be 180 degree. Now wind is coming from taller side, it will be 0 degree. So this is the condition, this is 0 degree. And if wind comes from the shorter direction, it will be 180 degree. Now how much is H and how much is L? Half. This half is H and half is L. This is H and this is L. So for H, the CP value is -1. For H, the CP value is -1. For L, the CP value is -0.5. And how much is CPI? That is the internal pressure coefficient. Internal is +0.5. Plus means push. +0.5 is actually pushing the face. So this is CP -1, -0.5, and CPI is +0.5. Now we have to consider the local coefficient also. Local coefficient is very important. And how much will be the local coefficient? For local coefficient, we know that local coefficient is applicable when y is equals to minimum of H and 0.15 W. Now this minimum value H is for our case H is 15 and 0.15 W will be 3.75. So the value will be 3.75. So we will consider the local pressure coefficient will be up to 3.75, but this is in plan, this is in projection, not in the roof. That means if we consider the projection here, this value will be 3.75. Here also, in this side also it will be 3.75, the zone of local pressure coefficient. But in roof it will be, this length will be 3.75 by cos alpha. Alpha is 10 degree, so it will be 3.81. So up to 3.81 length, this is 3.81. In projection it will be 3.75. At that zone the CP will be here -2. We will consider the higher value of H1 and H2. H1 and H2 because as in the previous figure we have shown, in one previous figure I have shown that if suppose this is the roof, then this angle is 0 degree, this is 45 degree, this is 90 degree, and then it is 135 and 180 degree. Our code is saying that up to W it will be H1 and after that it will be H2. And here up to W it will be L1, then it will be L2. But wind can rotate like this also, 0, 45, 90 like this, or 45 can be this angle also, 45 this angle, or 90 this angle, this can also happen. The orientation can actually change. So H1, when we are considering wind in this direction, then H1 will be this side. But when we will consider wind from this direction, then it will be H1. So it is better if we consider the value of H1 throughout this local zone. And if we consider L1 for all this local zone, then it will be better. Because H1 is higher than H2 and L1 is higher than L2. So if we consider the higher value, then from design point we will be on a safer side. So for the lower side, for the local coefficient, we will consider the higher value for L1 and L2. Higher means -2 and -1.5, so it will be -2. So these are the CPE. And for this portion, the overhanging portion, it will be same like the adjoining portion. So it will be again -2. And again in this portion also it will be -2. So all these are from the upper side. In lower side, for this portion, this is actually a roof which is on a windward side, but this is not a downward slope. This is a upward slope. For upward slope, the value will be 0.75. And here in this portion, here actually we have to consider the value of the adjoining wall. So how much is the value for the adjoining wall? For adjoining wall, this wall is actually, if wind is coming from this direction, this is 0 degree, then this is A, this is B. So here 0 degree, the value is B -0.3. So here it is -0.3. So -0.3 means it is always, plus means pushing, minus means pulling. So it will be like that. minus 0.3. So it is pulling. Here 0.75 positive pushing, minus 0.3 pulling. So now if we go for the resultant, like Cp minus Cpi, or here the resultant value, then how much will be Cp minus Cpi for all this case? Here minus 1 minus 0.5, minus 1 minus 0.5. So it will be minus 1.5. So here the resultant will be minus 1.5. Here how much resultant? Minus 0.5 minus 0.5. So it will be minus 1. So here it will be minus 1. Minus 2 minus 0.5. So it will be minus 2.5. Here it will be minus 2.5. Again here also minus 2 minus 0.5. So it will be minus 2.5. So again it will be minus 2.5. Here minus 2 minus 0.75. So it will be minus 2.75. Here minus 2 minus minus 0.3. So it will be minus 1.7. So here it will be minus 1.7. So this image is actually, the image has actually messed up. So if we go for the next slide and if we use similar value, then it will be clearer to you. Now again, this is CPI is minus 0.5. CPI minus 0.5 means it is actually pulling this phase, minus 0.5. So first we will divide this particular case. This is the zone of local coefficient. Then this is the H portion. This is L portion. And again this is the zone of local coefficient. And these are the overhanging portion. Now how much is CPE here? Here CPE is minus 1. CPE minus 1. Here it is minus 0.5. For local zone here it is minus 2 and here also minus 2. This is this portion. H1 and H2 the higher value we are considering, so minus 2. L1, L2 the higher value we are considering, so minus 2. For this overhanging portion in this zone, it will be same like this, minus 2. And here also it will be same like this, so minus 2. So this is in the upward side. In the downward side it is minus 0.5, which is CPI here. And if we consider this portion, if we consider this overhanging portion, this overhanging portion is on the windward side because wind is coming from 0 degree. So here actually, if we are considering the windward side, then it will be plus 0.75. 0.75. And here we have to consider the CPE of this portion. So here we know that from this table it is minus 0.3. So here also it will be minus 0.3. So this is the value. So if we clear this image and if we write the CP minus CPI, so here CP is minus 1. So minus 1 minus minus 0.5. So it will be minus 0.5. Minus 1 plus 0.5. So it will be minus 0.5. So CP minus CPI will be how much? In this zone, it will be minus 0.5. Here it will be how much? Minus 0.5 minus minus 0.5. So it will be 0. So here in this zone it will be 0. 0. Here minus 2 minus minus 0.5. So it will be minus 1.5. Minus 1.5. Minus 1.5. Here minus 2 minus minus 0.5. So it will be minus 1.5. So it will be, here it will be minus 1.5. In this zone it will be minus 2 minus resultant minus 0.75. So it will be minus 2.75. So in this zone it will be minus 2.75. Minus 2 minus minus 0.3. So it will be minus 1.7. So it will be minus 1.7. Because minus 2 is acting on this direction, minus 0.3 is acting on opposite direction. So these two will balance each other. So it will be minus 1.7. Minus 1.7. So this is the calculation of CPE minus CPI when CPI is minus 0.5 and wind angle 0 degree. Now this is when wind angle is 90 degree. 90 degree means this is our monoslope roof and wind is coming from this direction. This is 90 degree. 90 degree. So neither this side nor the opposite side are windward direction. So both these are not windward direction. So now first we write the value of CP. So our angle is 10 degree, our wind angle is 90 degree. Here not 0 degree, it is 90 degree. Our wind angle is 90 degree. So for H and L, up to some portion we will consider -1, and after that we will consider -0.5. So for H and L, up to certain distance we will consider -1. After that we will consider -0.5. But what I have already said repeated time, that this can be 90 degree, this can also be 90 degree. So the position can actually change. When wind will come from this direction, this is 90 degree. At that time, this will be -1, this will be -0.5. This will be -1. So orientation of wind angle is very important. If wind comes from this direction, then it will be -1 and it will be -0.5. So we do not know that which one is 90 degree. So it is better if we consider the higher value. For design purpose, it is better if we consider the higher value. So higher value is how much? Higher value is among these two value, the higher value is -1. So for both H and L, we will consider -1. -1. For local zone is how much? Local zone is, this length is 3.81. In projection, it is 3.75. This is local zone. In projection, it is 3.75. So here the value is -2, higher of these two value, -2 and -1.5. And L1, L2, the lower side, it is also -2. This is the higher of these two value, this is the higher of these two value is this, and higher of these two value is this one. And in this portion, it will be also same like this adjoining portion, so it will be also -2. And in this portion, it will be also same, -2. Now this is for all the upward portion. Now how much will be for the downward portion? How much will be at the down? CPI is how much? CPI is +0.5. Plus means push. So it is +0.5. And in this overhanging portion, how much? And in this overhanging portion, how much? Now this is 90 degree wind angle is this. This is 90 degree. So when wind is coming from 90 degree, both this overhanging portion, these are now not windward portion. This portion are not now windward portion. This portion are side portion, different portion. So for this, we will consider the CP of wall for these two slope. So for this wall, this is actually A, this is B. Here -0.5 CP, here -0.5. So -0.5, and here also -0.5. We will consider in the downward side of the overhanging portion. -0.5, because the CP of this overhanging portion, these two portions are not the windward portion. So in this portion, we will consider the CP of the wall same with this CP of this overhanging portion. So -0.5. So what will be the CP minus CPI? What will be the CP minus CPI? So here it will be -1 minus 0.5, because CPI is 0.5. So -1 minus 0.5. So how much it will be? -1 minus 0.5 will be -1.5. So it will be -1.5. Here it will be -1.5. Again here how much? -1 minus 0.5, it is again -1.5. Here -2 minus 0.5. So it will be -2.5. So in the local zone, in this local zone, it will be -2.5. It will be CP minus CPI will be -2.5. Here also local zone, -2 minus 0.5, so it will be -2.5. And in this overhanging portion, -2 minus -0.5. So it will be -1.5. So here in this zone of overhanging portion, it will be -1.5. And in this zone, -2 minus -0.5. So again it will be -1.5. So in this zone it will be, resultant will be -1.5. So this is the CP minus CPI for different portion. When wind angle is 90 degree and CPI is +0.5. Now again same problem, but here CPI is +0.5. So I am repeating it again and again, because at that time it will be easier for you to understand, because calculation is more here. So now again the angle is 90 degrees. So this is H, this is L, and for both H and L we will consider the value -1, because -1 is higher than -0.5. So here we will consider -1 CP, here we will consider -1. The local coefficient, how much? It will be here -2, here also -2. For H will -2, for L also it will be -2. So here it is -2, here it is -2. And in the overhanging portion, it is same like the adjoining portion. So it will be -2, it will be also -2. In downward portion, our CPI is how much? CPI is, sorry, it is -0.5. Previous case was +0.5. So CPI is -0.5. Minus means pull, -0.5. In the overhanging portion, this is overhanging portion, the value will be same like the wall. For wall, the value is -0.5. For this wall is also the value is -0.5. So here also it will be -0.5 and it will be -0.5. So resultant will be CP minus CPI like this. So here -1 minus -0.5. Both are acting in opposite direction. You can see that these minus are actually acting downward here. These are acting upward. So these two will counter each other. One will decrease the value of other. Here also the same thing. This is upward, this is downward. This is downward, this is upward. So all this value will actually decrease. So -1 will decrease, -1 minus -0.5. So it will become -0.5. Here also it will -1 minus -0.5. So again it will become -0.5. -2 minus -0.5. So it will be -1.5. 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 So this will be the resultant value of CP minus CPI for all this case. I hope you have been able to understand that how we can calculate the value of CP minus CPI for different cases. CP minus CPI for different cases. Now this is the most important thing. After we calculate the value of CP minus CPI, now the next task is very easy. When we will calculate the value of CP minus CPI, rest part is very simple. We have to only calculate the value of tributary area and then we have to multiply by the PD. So already I have said that if there is a purlin like this is the purlin, this is next to purlin, 3 purlin like this. So if we consider one purlin like this, how much will be the influence of it? Influence will be half in both sides. This particular load will come over this particular purlin. The load of this particular area will come over this particular purlin. So how much load will be taken by this particular purlin? We will consider this as the tributary area. For the next purlin, it will be like this. This is the tributary area and this zone, the load of this zone will come over this particular purlin. So half from this side and half from the another side. This particular zone will come under the effect of this particular purlin. Or if we consider one node, like this here, then it will be the tributary area. For a node like this, if there is some node, different node like this, so for one particular node, if this is one node, its tributary area will be half in left, half in right, half in top and half in bottom. This total area will come in under the influence of this particular node. So this will be the tributary area or influence area of this particular node. So multiplying the value of CP minus CPI with this tributary area and then multiplying by the value of PD, PD is the design wind pressure, we can calculate the total wind force by using this equation. How to calculate the value of PD and how to calculate the wind force for a rectangular clad building and also how to calculate the wind force for a pitched roof, all I have discussed in the previous videos. So it is better if you go for the previous video first and then after you come for this particular video, then it will be easier for you to understand. So that is all for today. Thank you. I hope you have able to understand all this thing. Now if you have any type of question, you can ask that in the comment box. Thank you for your attention. Thank you.